Here we are given a solution to a second-order differential equation, and we know that it's second order because there are two arbitrary constants c sub 1 and c sub 2. We are also given two conditions, one condition on the solution and the other is on the derivative. And we will be looking for the particular solution by solving for c sub 1 and c sub 2. So we start by writing down the solution to the differential equation. So this is the general solution. And then we write down the two conditions. Y sub 1 equals 1, and the other one is y prime 1 equals negative 1. And for the first condition, it is just a simple substitution. So we substitute the value of x here into the given general solution. And so that becomes, so let's just write 1 in front. So 1 equals, so this becomes this one. So 1 equals y of 1. And y of 1 is just, so we just substitute 1 for all x's in the given general solution. So c sub 1 e to the 1 plus c sub 2 1 times e to the 1 plus 1 times e to the 1. Or simply, that's just c sub 1 times e plus c sub 2 times e plus e. So this is our first equation from the first condition. Let's call that equation 1. And now we go to the second condition, and we are given a derivative. So the first thing we do is we differentiate the given general solution. So if we differentiate that, that becomes y prime of x. Derivative of this is just c sub 1 e to the x. The derivative of this is c sub 2 times 1 times e to the x plus x e to the x. And lastly, the derivative of the last term is 2x e to the x plus x squared e to the x. And now we just substitute the given here. So let's put negative 1 first. So negative 1 equals y prime of 1, and let's substitute the 1's here for x's. So c sub 1 times e plus c sub 2. Then we just have e plus e, and then we have 2e plus e. So let's simplify that a little bit. So let's combine the c sub 1's and c sub 2's. And now here we have our second equation from the second condition. Now we have two unknowns, c sub 1 and c sub 2. We are given two equations, equation 1 and equation 2. So we can do our techniques in algebra to actually solve for c sub 1 and c sub 2. And here I'm just going to eliminate c sub 1 first. So what I'm going to do is I'm going to subtract equation 1 from equation 2. So that will eliminate c sub 1. And what I have is negative 2 equals c sub 2e plus 2e. And then if I just rearrange that a bit, that will give me c sub 2 equals negative 2, 1 plus e all over e. or we can have negative 2 e negative 1 plus 1. So this is our c sub 2. Now to obtain c sub 1, we just substitute this value here in either equation 1 or equation 2. Let's choose equation 1 because it looks simpler. So what we'll do is substitute c sub 2 in equation 1. So equation 1 now becomes 1 plus c sub 1, or rather 1 equals c sub 1e plus c sub 2e plus e. So let's just substitute c sub 2 for, and let's use this for c sub 2. So probably this is better to use. So let's have negative 2 times 1 plus e over e times e and plus e. Let's just simplify that a bit. What we obtain is negative 2 minus 2e plus e. These things cancel. And then we have c sub 1e minus 2 minus e equals 1. And if we just rearrange that again, we get c sub 1 equals 3 plus e over e, or 3 times e to the minus 1 plus 1. And this is our c sub 1. And so we now have values for c sub 2 and c sub 1. And if we just substitute that in the original equation, we get the particular solution for this problem.